Hello, Salma. I'm just going to try and help you with this isomers question here. Just reading it as I talk. So we've got three pairs of isomers, and we have to give the structural formula of each from A to F using infrared absorption data on the data sheet. Okay, so presumably you've got a data sheet you can refer to at hand. So that would be good. Okay, so let's do C part 1 first. So they've got the formula C3H8O. All right, A has a broad spectrum band at 300, all right, 3,300 cm to the -1. And that tells us that we've got an OH bond from an alcohol. All right, for A. All right, so let's draw A out here. So A is going to be, and we'll do the structural formula. So if you need an alcohol, let's give its functional group at the end. All right, and we've got three carbons, so it's going to be CH3 and a couple of CH2s and an OH group. So that's going to be A. Now B has the same molecular formula, C3H8O, but it doesn't have an OH group, so it's not an alcohol. Okay, so looking at this, I suppose going through what it could be an aldehyde, but if it was an aldehyde, you would need an extra hydrogen. Right, so it can't be an aldehyde. So let's try it. So and that would mean it can't be a ketone either. So let's think if we could make a ester out of that. All right, so yeah, I think an ester is going to work. Let's look through it. So B, we want an ester. So we're going to have a CH3 group. We're going to have a CH2 group. And then we're going to have an oxygen ester link, right, and then a CH3 group, like so. Just to make this clear, let's just draw the displayed formula out as well, even though the question's asking us for structural formula. So you've got the CH3, a CH2, then we've got our ester link, and then we've got another CH3 group here, like so. And then counting up the hydrogens, we've got 8 hydrogens there, 3 carbons, and an oxygen. So that looks good for B. Okay, so moving on to part 2. Let's switch colour for a change. Let's do part 2 over here. So now we've got C5H10. So the first thing that, because we've only got carbon hydrogen, the first thing that goes through my head is alkanes or alkenes. Alkanes would be CnH2n plus 2. So that doesn't work. So it must be an alkene. The general formula for alkene, you remember, is CnH2n, right? Which is what we've got here. So we've got an alkene. We've got straight chain alkene. All right. Straight chain alkene as one of them, we think. Straight chain alkene. Now let's just check that 1650. We're hoping that that's going to be double bond, and it turns out when you look at your infrared table on your data sheet, yes, 1650 is a carbon-carbon double bond. So that's good. So we can draw. That would be for C. So let's draw C out. Let's put the double bond at the start. So drawing the displayed formula first, right? We'll have 1 hydrogen off here. So we want 5, right? So we need, right? So we've got 3, 4, 5, 6, 7, 8, 9, 10 hydrogens there, right? So that is our displayed formula, but the question's asking us for structural formula. So let's say CH2, CH, CH2 twice, condensed structural, we get away with that, and CH3 on the end. So this is a condensed structural, but the mark schemes always allow you to do that. You could write CH2 twice instead if you want. Okay, so there we have C done, but D does not. Okay, so it's got the same molecular formula, but doesn't have a double bond in it. Okay, so that points me straight to a cyclical formula, because when you join the two ends of a hydrocarbon up, you lose two of the hydrogens, of course, because two of the carbons bonded to it instead. So then you're going to have, we'll draw the display formula out. We're going to have 5, so that's going to be in a pentagon shape, right? And so you're going to have, and essentially that shape would be the formula, but bear in mind you've got 2 hydrogens off each of these carbons. Okay, so like so, but it wants the structural formula, so that's just C5H10, like so, because it's cyclical. Okay, so that has 5 carbons, 10 hydrogens, and no double bond, so that works for D. Okay, switching color again. Let's go green this time. E and F, molecular formula C3H6O. 1700. All right, so let's look up 1700 and we find a carbonyl group for 1700. I'm going to change to black. That color's not working really on the white background. So we've got a carbonyl group at 1700. And hey presto, here look, we've got tolerance. Okay, so we've got an aldehyde and a ketone. So let's just draw those out. Aldehyde, we have the carbonyl at the end. Okay, so we're going to draw our aldehyde like this, displayed formula first. How many carbons? We've got 3, so we're going to have, it's going to be like so. With hydrogens on the end of those bonds. Okay, so structural formula is going to be CH3, CH2, CHO for aldehyde. And remembering that we write aldehyde CHO. And then let's write the ketone out. So the ketone is going to be displayed formula for the fullness of it. We're going to have the ketone like so. So again, so we've got 6 hydrogens there, 3 carbons, and an oxygen, right? So that's going to be CH3, CO, CH3. So there we have it, A through F structural formulas done. I hope that's helped.